Okay, so we're going to solve word problems. All right? Anything that we learn for a purpose, and the purpose is to actually use these, whatever we learn, for application questions. Okay? Because in real life, it's not going to be, you have 2 points, find the vertex. It's not going to be like that. It's going to be an actual word problem. So a grid has been superimposed on the Gateway arc in St. Louis. Find the equation that models the arc. Okay? So what's the question asking you for? Find the, right? So this is your arc, and what they did is they put an x and y axis on the arc, okay? They put an x and y axis on the arc, and they want you to find the equation according to this x and y axis. We know this is a quadratic function because it has a parabola shape, yes? Okay. What do we know from this arc? What points do I know? I know a point x and y, so I have 2 different points. I can pick either one. So this is going to be 3 and negative 4. So let's pick that one. This is x and y. Do I know what my vertex is?
No. 0.
Where is the vertex? It's at 0, 0. That's where your vertex is, right? So your vertex is right here, and it's at the origin. So that's at 0, 0. Okay? So is that enough information to find my equation? Yes. Remember that I need 2 points to be able to find the equation. One of them is the vertex. Okay? What's the vertex form? Y equals what? Okay? So I start with the vertex form. Okay? What do I plug in first? The vertex which represents h and k. So y equals a x minus 0 squared plus 0. Then what do I plug in after that? 3 and negative 4. You can pick either point. It doesn't matter as long as 1 point. I picked this one because just 3 is positive. I like dealing with positive more than with negative. You can pick either or. You should get the same answer. Okay? So what do I plug in for y? Negative 4. And then what do I plug in for x? Now let's solve for a. The whole purpose of this is to find what the a is, right? Bedmath says I have to do my brackets first, so 3 minus 0, that gives me 3. 3 squared gives me 9 plus 0. Do I need to write that plus 0? 9a plus 0 is the same thing as 9a. Yes? Then what's the last step? Bring over the 9, and what does it become? It stays positive, but what happens to it when I bring it over? How do I isolate for a? Divide by 9, right? Because it's a multiplication here. The opposite of multiplication is division. So that means my a is negative 4 over 9. Right? So remember that if you have a coefficient for the a, you're going to have to divide by it. So that means my equation is y equals negative over 9. Does it make sense that it's negative? Yes. It opens down, exactly. Do I need to write that x minus 0? Or can I just leave it as x squared? Like this. X squared, right? That minus 0 plus 0, I don't really need. Okay? Because x minus 0 is still x, so that's x squared. And then that plus 0 on the outside, I don't need. So my final equation is negative 4 over 9 x squared. Are we okay with that? Any questions about this? All right. A football was kicked. Its path can be modeled by the relation h equal negative 0.1 bracket d minus 8.7 squared plus 7.6, where h is the football's height above the ground and d is the horizontal distance from where the football was kicked, both in meters. Okay? So h is the height, d is the distance from the kicker. So, what is the vertex of the parabola?
8.7, 7.6.
Do we agree with that? Yes. The vertex is coming from the h and the k. Right? Remember, this is the same thing as y equals negative 0.1 x minus 8.7. If I change the letters, that doesn't mean I changed my equation. Okay? But instead of y, I'm using height. Instead of x, I'm using distance. Okay? So the vertex of the parabola is 8.7, and comma 7.6. So what does that mean? What do the 8.7 and 7.6 mean? What do they represent in this scenario? The vertex. But when I'm thinking about the real life scenario, what does that represent? So remember, the football is going to be kicked, right? It's going to start and then it's going to go up and then it's going to go down and then hit back the ground, right? So this is my vertex. So what does that represent? The highest point, right? The highest point that your football has reached, right? Now, what was the highest point that the football reached? What is it? Remember, guys, please pay attention to this because you're going to have questions like this. So if you look at this, the y represents what? What does the y value represent? The height. Looking at this vertex, which is 8.7 and 7.6. Now, can you tell me what is the highest point that the football has reached? 7. When did it reach that 7.6 meter? 8.7 meter from the kicker. Remember, the kicker is standing right here, right? And he's kicking the ball. Or she's kicking the ball. Okay? So, the ball went up, reached the maximum height, then went back down and hit the ground. At that point here, that's your highest point. So that's 8.7 meter away from the kicker at the maximum height of 7.6 meter. Can you visualize this now? Yes? All right. Now, if I'm looking at the football's initial height, so what point am I looking for? What does initial mean? At the start. So how high was the football at the start? No. Is that at the start? Was it at the highest point at the start? Yes, but the question is asking you, what is the height of the football initially? So at the start, what was the height? How do I find that? What is the distance? Okay, where's the football? Here's the football. I am kicking that football, right? it's right here and I'm kicking it. How far is the football away from me right now? How far? What's the distance between me and the football? There's no distance, which is what? What's that number? 0, right? So the initial distance between the kicker and the football is 0. So that represents that the distance between the kicker and the football is 0. This is how I always find my initial. To find the initial value, you always have to plug in 0 for whatever represents your x. Okay? So if this represents my x, right, that means I have to plug in 0 in that in place of d in order for me to be able to find the initial height. Bedman says I have to do the brackets first, so I did inside the bracket. Then I have to do my, what is it called? The exponent. So I did my exponent. Then now I have to do the multiplication with a negative 0.1. Then my answer is 0.031 meters. So that tells me that the football was not on the ground. It was a little bit higher than the ground, right? So they have it either on a leg or something, on a post or whatever, so the person can kick it. So here's a side note for you that is always going to happen. So anytime you're looking for initial value, which is y, you're going to plug 0 for whatever represents the x, okay? So in this case, x is your distance. Okay? So anytime you're looking for an initial value, you're going to plug in 0 for x or whatever replaces x. Does that make sense to you guys? So what points do I know so far? What points do I know so far? Yeah. Where's the vertex? Where's the vertex? Okay. And then I know my initial, right? What's my initial? 0 and 0.031. Okay? So I know these 2 points. So I need these 2 points to graph them. Okay? So I'm going to make my own graph here. So I'm going to change my axis. So this is my distance. Where is the in meters. And this is the height in meters. You see how I'm labeling my axis? You see how I'm putting my units? Okay? All right, so let's put some values on my x and y. So I'm going to pretend that this here is my 9, 6, no, that's way too close. Okay, so I know, let's say this is 1, 2, 3, 4, 5, 6, 7, 8. So I know my first point is at 0.031. So if you look at this one, if I'm going to place this point, I'm going to have to place it somewhere close to the 0, but not at the 0 yet, right? So this would be my first initial value, okay? Then to place 8.7 and 7.6, 8.7 is close to 9, and 7.6 is almost in the middle between 7 and 8. So it's almost right here. So far I only have 2 points. I need at least 3 to be able to graph, okay? I know that a quadratic function is a symmetrical function, right? And the symmetry is going to be around the axis of symmetry. So if I have an axis of symmetry here, right, that means if I go from here to here, then I'm going to have to be able to come down exactly in the same way. Does that make sense to you? So then, to this point, it's going to have to be exactly equal to from this point to the other side. Okay? This is at 0 and 0.031. And there's 8.7 meters. If I'm looking at this, that's 8.7, right? If I add another 8.7 on the other side, 8.7 plus 8.7. 17. So that means my x is going to be 7.4 and 0.31. Okay? Let me repeat that for a second. 17.4 and 0.031. If this part here is 8.7, right, from the axis of symmetry to my original point, right, there is 8.7. So that means because of the symmetry, I can find another point that's exactly the same distance from the axis of symmetry to the end. Does that make sense to you guys? Does that make sense?
Yes.
Okay? So basically, this is the pathway of the football. Yeah. So if I go back here, I got 0.031 from here. Did I write 1.3? No, I wrote 3. No, I subtract. So this is minus 7.56 plus 7.6. Yeah, so you do minus 7.56 plus 7.6. Do you guys see that? Do you guys see what I did? I only had 2 points, the vertex and the initial. And that was enough for me to be able to draw the rest of the parabola. When you do what? It's probably because, which is your right, I think. Wait. Yeah, you guys are right. I don't know what's wrong with my calculator today. Yeah. Okay, there's a mistake here. Thank you, guys. So this is supposed to be 0 point. You know why? I think no, I did. Because I used, I'm missing a number there. I'm missing a number there. This should be 569. Okay. So that was right.
Why did you leave it 75? Like, why did you change the decimal?
It was actually 7 point. What do you mean?
Like over there, you see 75.69, and then.
But when you multiply it by negative 0.1,
Oh, that's what it is.
that's what it becomes.
Oh, okay.
Okay? It's just me when I was writing, I missed that 9. Okay? All right. So we already talked about this. What the vertex represents in terms of the football path. We know that the football reached a maximum height of 7.6 meter at a horizontal distance of 8.7 meter. It's very important that you guys understand the question and then what the points represent in terms of the question. Okay? All right, here's what I want you to do. There is one more word problem, which is this. We're going to look at what you guys can do when to work on this question. Work on this question with other people, and I want to see what you guys can get out with. So the vomit comet is the nickname of a jet used to simulate zero gravity, 0G. Don't worry about the names. This is just names and introduction. There's nothing to that. To simulate zero gravity, the jet flies in a parabolic arc starting at an altitude of about 7,300 meters. After climbing for about 30 seconds, the jet reaches its maximum altitude at about 9,800 meters, where the weightlessness effort occurs. The jet descends back to an altitude of 7,300 meters, about 60 seconds, and then repeats the process. Sketch a parabola, write a quadratic relation to model the path. The parabola also passes through the point 319799.999. So, I want you to reread this question. I want you to gather what information do you know to be able to graph, and you have enough information to be able to graph. Then you're going to find the quadratic relation, but I want you to use this point as x and y. Don't use any other points as x and y. You're going to have to find your vertex. You need it. But use these points for x and y to find your equation. Okay? Work on this question with other people, please. So find another person to work with, and then we will discuss it when you guys are done.